This recording is intended to follow up on our conversation in class today regarding the law of cosines, specific to the case of side, 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 when we are given the measurements of three different sides. This was the example that we left off with. We were given that side A had a measurement of 8, side B had a measurement of 19, and side C had a measurement of 14. The question was raised which angle should we solve for first, and we chose to solve for angle A first, receiving a value of 22.07 degrees. And then I posed the question, does it matter which one we solve for first? And there was a little debate. Well, I declare to you that it does matter which one we solve for first. So let's take a look at the features of sine and cosine and what happens when I get negative values versus positive values, and how that affects the type of angle that I will compute, whether that angle is acute or obtuse. Now, whenever cosine of a value is negative, when cosine of A is less than 0, then we know that we have a value of an angle that's in the second quadrant. And when that angle is in the second quadrant, now, when cosine of an angle is less than 0, then that means that that angle lies in the second quadrant. And we know that second quadrant angles are between 90 and 180 degrees, which means I'm looking at an angle that is obtuse. If this is the case for our law of cosines, then we know automatically that our other two angles are acute. If cosine of the angle is greater than 0, then angle A is in quadrant 1, which means that A is between 0 and 90 degrees. Hence, we're working with an acute angle, which lets us know all of our angles are acute. And again, this is assuming that A is the largest angle. And so for that reason, if we're using the law of cosines, then we want to make sure that we solve for the largest angle first. And again, this is specific only to the side, side, side scenario. So in keeping with that, let's redo this example. We can see that the largest side is 19 units long, which is across from angle B. That tells us that B is the largest angle, so this is the one we'll solve for first. Law of cosines, we'll have B squared equals A squared plus C squared minus 2AC times the cosine of B. And so substituting some values in, we have 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. After some numerical computations, we'll end up with 361 equals 260 minus 224 times the cosine of B. Remember to respect your order of operations. You cannot subtract 260 minus 224 here. This 224 is being multiplied by the cosine of B. So subtracting 260 from both sides, we have 101 equals negative 224 times the cosine of B, which means that the cosine of B is negative 101 divided by 224. And you can change that to a value in your calculator. Now, if we solve for angle B by using inverse cosine, we'll find that we get about 116.8 degrees as the measurement for angle B. Now we can use law of sines, and law of sines can help us since we now have two sides at an included angle. in that we have side A, side C, and angle B, I can now solve for angle A. Now, unlike cosine, sine cannot distinguish between acute and obtuse angles. And this is because in the first quadrant, sine of an angle is greater than 0. And also in the second quadrant, sine of an angle is greater than 0. So if I get a positive value for sine, I really don't know if it's supposed to be an acute or obtuse angle because I don't know specifically before I begin which quadrant to expect. So for that reason, whenever I'm using law of sines, we're going to solve for the smaller side first, which is why we chose angle A here. Now for law of sines, I can say that B over sine B equals A over sine A. We know that B has a measurement of 19 as a side. We're looking for the sine of angle B, which is 116.8 degrees, and that will equal 8, which is the measurement of side A, and we're going to be solving for the sine of angle A. So by the time I cross multiply, simplify some things, I'll have that sine A equals 8 times the sine of 116.8 degrees divided by 19. And then if in your calculator you do the sine inverse of all of that, 8 times the sine of 116.8 degrees divided by 19, you'll find that A equals about 22.08 degrees. Now, if you remember from the other example, that's the same thing that we had before, which is not a problem, and we'll talk more about ambiguous cases for law of sines tomorrow. We just want to be sure that we are solving for the largest angle first whenever we use law of sines. Now I can just use the fact that the three interior angles of a triangle have a sum of 180 degrees to solve for angle C. So now I can use the fact that the sum of the interior angles of the triangle add up to 180 degrees, and I can find angle C by taking 180 minus the measurement of angle A, which is 22.08 degrees, minus the measurement of angle B, which is 116.08 degrees. And I'll find that C has a measurement of about 41.12 degrees. And now I have solved my triangle. If you have questions about these, feel free to ask tomorrow. Make sure you check the blog notes so that you can see the homework, and we'll talk about area of the right triangle as well as the ambiguous case of law of sines tomorrow in class.